Greetings, my name is Scott Cedarquest, and I want to thank you for tuning in to this pre-recorded ASABE webinar concerning updated braking recommendations for towed agricultural equipment. This is part 2 of a 2-part series. I have been part of the ASABE staff since 2001 and am pleased to introduce the topic and speaker today. I want to start by explaining the origin of these webinars. They were developed to explain the content in the new 5-part ASABE braking standard to manufacturers of towed field equipment. In fact, we had support from all 3 North American trade associations in promoting these webinars to their members. These 3 groups also faithfully circulate press releases and other standards development information to their members throughout the year. The material is now being provided to you as an attendee at the ASABE Annual International Meeting. The format today is simple. The recording of the webinar will be played on demand along with the recorded Q&A session from when it was presented to the towed implement manufacturers. If you have questions that are not answered by viewing the recorded Q&A portion of the webinar, please let me or Carla Van Gilder know. We will pass your question or questions along to the ASABE Braking Committee for consideration. I also need to say a few words about ASABE. You may or may not know that we are the primary standards development organization in North America for agricultural equipment systems. We currently publish over 280 national standards and represent the U.S. in 15 distinct ISO committees or subcommittees. The majority of this work is related to equipment design. All ASABE committees are open. Now I will introduce the main presenter. Today, Bruce Hawkins will be presenting on the new 5-part ASABE braking standard. Bruce is a 10-year member working as an engineer for John Deere. He was also the project lead for the development of these standards. This is the second part of a 2-part series covering updated braking recommendations for towed agricultural equipment. If you have not yet viewed part 1, it is suggested that you do so before watching the second part. The first webinar helps you determine if your equipment should be equipped with brakes. For equipment that does require brakes, in this webinar, Bruce helps explain how to select the right amount of braking capacity for the implement. With that, I now turn it over to Bruce.
This presentation will be focused on ASABE S648 agricultural field equipment braking. This standard consists of Part 1, General Requirements, Part 2, Requirements for agricultural tractors, Part 3, Requirements for self-propelled and special self-propelled machines, Part 4, Requirements for towed vehicles, Part 5, Requirements for the interface between towing vehicle and towed vehicles. This standard was not created for regulation. It was developed as a voluntary standard. However, compliance to a voluntary industry standard may provide some protection from litigation. Today's focus is on Part 4, Requirements for Towed Vehicles, and also introduces content from Part 5, Requirements for the interface between towing vehicle and towed vehicles. Topics that will be discussed today are: how much braking or deceleration does my towed vehicle need? How to go from deceleration to brake force to brake sizing, and compatibility, towing and towed vehicles. To review, this graphic shows the criteria for the 4 tractor and towed vehicle classes. Note that the classes are determined by both the maximum transport speed and the maximum transport mass ratio. Recall that the maximum transport mass ratio is a function of the maximum transport mass divided by the minimum recommended mass of the towing vehicle. Each class has a minimum deceleration rate. The first column defines the rate for the combination of the towing and towed vehicle when hitched together. The second column defines the deceleration rate for the towed vehicle only. This diagram is a simplified illustration of a towed vehicle during braking. It is shown as a trailer but could be an implement. The direction of travel is to the left. The brake force, the force being transferred from the ground to the tire, is to the right. This force is opposite the direction of travel. What values are known? Mass and the desired deceleration rate are known. What is unknown? The amount of brake force to provide the desired deceleration with the given mass. The formula used to determine brake force is shown. Brake force equals mass of the towed vehicle multiplied by the desired deceleration. It is based on Newton's second law, which means a force acting on an object is equal to the mass on an object times its acceleration, or in this case, deceleration. Once total brake force is determined, the individual brake force per wheel can be calculated by dividing brake force by the number of braked wheels. Keep in mind that a dual tire arrangement where two adjacent wheels are attached together are treated as one braked wheel. Once brake force per braked wheel is determined, the minimum brake torque can be calculated. This is done by the formula shown, where brake torque equals brake force per braked wheel multiplied by the rolling radius of the wheel. Generally, the rolling radius value can be obtained from the tire manufacturer. Brake torque per wheel corresponds to torque that needs to be generated by a brake component. There are several options available for braking components. These can be dry, which are typically air-cooled, or wet, which are typically oil-immersed. Typical dry brakes either are disc type or drum type. Wet brakes typically are of the friction disc and separator plate design. Once brake torque per wheel has been defined, a brake assembly can be sized. The minimum brake torque is required to occur when coupler pressure is at the values defined in the slide. A common method for this is to use actual pressure from the coupler to actuate the brake assembly. Other possibilities are to use coupler pressure as a pilot to actuate a relay valve. A separate supply and tank line may be needed for this and is most likely limited to hydraulic brake systems. The intent of the standard is for trailer brakes to be actuated with the brakes of the towing vehicle, effectively allowing both hands of the operator to remain on the steering wheel. An example from the first webinar will be continued. In this example, a towed vehicle maximum transport mass was defined at 21,818 kilograms. The recommended minimum towing vehicle mass was 5,454 kilograms. The towed vehicle classification from ASABE S648-4 was a high mass, high speed towed vehicle. The minimum deceleration rate defined in ASABE S648-4 for this class is 5 meters per second squared. There are 4 braked wheels on this example, and each wheel has a rolling radius of 1 meter. The brake force for the towed vehicle is calculated by multiplying the mass times the minimum required deceleration rate. In this case, the mass of 21,818 kilograms is multiplied by the minimum deceleration rate of 5 meters per second squared. The minimum brake force is 109,091 newtons. The brake force per braked wheel is calculated by dividing the brake force by the number of braked wheels. In this case, with 4 braked wheels, the brake force per wheel is 27,272 newtons per wheel. The brake torque per wheel is calculated by multiplying the brake force per wheel and the rolling radius of the wheel. This results in a torque of 27,272 newton meters. This value can be used in collaboration with a brake component supplier to adequately size brake components. The last topic I wanted to discuss today is an explanation of the towing compatibility, or how coupler pressures are determined. When the operator of a towing vehicle applies the service brakes, the towing vehicle determines the amount of deceleration that is being requested. This can be based on brake application info such as brake pedal position, service brake apply pressure, etc. The vehicle then commands the corresponding pressure from the towing vehicle compatibility chart to the brake couplers. The chart has been created to allow adjustment by the operator to accommodate an empty towed vehicle versus a fully loaded towed vehicle. This is similar to the brake gain adjustment used with pickups and on-road trailers. The maximum pneumatic coupler pressure will not exceed 750 kPa, and the hydraulic coupler pressure will not exceed 13,300 kPa. As an example, a tractor is being commanded to stop at a 0.5 G deceleration. This horizontal line represents 0.5 G deceleration. The corresponding coupler pressure range for a pneumatic system would be 470 to 750 kPa, or 68 to 109 psi. For hydraulic, it would be 8,100 to 13,300 kPa, or 1,175 to 1,930 psi.
Hello, my name is Carla Van Gilder. I'm the Global Standards Administrator at ASABE, and I had the pleasure of working with Bruce on the braking standard projects. ASABE is an ANSI accredited standards developer, which means the development and approval of all our standards must follow the ANSI essential requirements for developing standards. My job for the braking projects was to work with Bruce and the development group, ballot the proposals to the committee, and to ensure all the proper steps were taken along the way. I want to share with you a variety of ways for which you can obtain the braking standards or any other ASABE standard. Each standard can be purchased individually. There is a discounted rate if 5 standards are purchased at one time. The braking standards are also available on the 2020 ASABE CD or flash drive, which also contains 276 other ASABE standards. Ordering information is provided on the slide. Every ASABE member gets 5 free standards annually as a membership benefit. If you are interested in becoming an ASABE member, please see our website for information on membership. If you are a FEMA member and would like a copy of these ASABE standards, please contact Vernon Schmidt at FEMA. Thank you for joining us today.
Greetings from Michigan, and thanks to Carla for that update. My name is Scott Cedarquest, and I have been the Standards and Technical Director at ASABE since 2001. We appreciate the interest from the viewers and all of the hard work Bruce and the ASABE Braking Committee put into the development of these 5 engineering standards. There's been a lot of interest in the development of these documents, and it seemed logical to share the details in a webinar format. Bruce has graciously offered to let me distribute the webinar details to the attendees. This will allow you to go back and review the information at a later date. This is much appreciated. In a minute, we will begin our Q&A session, but first, a couple of additional details. I can be reached at cedarq@asabe.org. During the Q&A, your questions can be entered via the chat feature located at the bottom of your screen. The question will be read and addressed as time allows. So now I turn the mic over to Bruce. Thanks for your interest. So this is Scott Cedarquest, and at the bottom of your screen, like mentioned, there's a Q&A feature at the bottom bar next to the chat feature and the participant number. If you would put your questions in there, we will go through these and try to answer them. So how do we access the presentations from part 1 and part 2 of the webinar was asked by Matt. We'll be sending you information on this in the coming days. The first thing we'll send is a PDF of part 2. If you didn't get the PDF of part 1, just ask Walter for that when he sends you part 2, and he'll send that as well.
All right, so this is Bruce Hawkins. Other question that first came up was related to the mass that we mentioned in the presentation, and And the question is, should we consider mass on the coupler or only mass on the wheels? So the way the standard's written, the mass is the mass of the complete towed vehicle. So it's the mass on the wheels as well as on the hitch. So we don't separate out the mass independently that way. There was a lot of discussion with that previously during development of the standard, and there's just a lot of variability between implement to implement, trailer to trailer, and it was hard to get agreement to look at separating that. So we went with just the mass of the trailer as it stands on its own.
I see in the chat feature another person would like to receive both copies of part 1 and part 2 of the presentation. So I think when we send out part 2, we will also resend part 1 so that if people who signed up for part 2 didn't receive part 1, they would. I don't see any more open questions up there right now. We'll give it another minute or two if people want to type in questions. Bruce, well, we're waiting for people to type in questions. I did have quite a few questions during part 1, and then even after that, people sent me notes about why didn't we follow what Europe had as far as the requirements there. Would you care to comment just briefly on the differences between what's in the North American standard and the European standard?
Yeah, I can. Yep, I can do that. So, so in Europe, there was a recent regulation, within the last 5 years, and it addressed tractors and towed vehicles, which was be implements and trailers. And there, in Europe, practices are different than here in North America. They do a lot of hauling of their produce and commodity with tractors and trailers. And the basis of that regulation really originated from their trucking industry. And so there wasn't a lot of differentiation relative to implements size so much and tractor size. And so they're anything above, I think it's like 1,500 kilograms or some number, moderately small number, required brakes, and they were brakes for both service and park brake. So right now in our standard, we have a fairly large area where we allow towed vehicles to not have brakes, up to 1.5 times the mass and up to either 32 or 40K in speed rating. So we really didn't we didn't feel there was a need for that much or to bring a brake requirement to implements of that size. So, and there's a comment too, I was wrong on the weight, it's 3,500 kilograms. So thank you.
Thank you, Oliver. Okay, are there any more questions that people would like to submit? We'll give it another minute here. Okay, we have one here. Are anhydrous ammonia transport tanks covered by these standards?
In effect, yes. Once they're used in the field as a part of the vehicle train, they would be included.
Okay. And Bruce, what about Canada? Do these braking standards affect products sold and used in Canada?
Well, as we mentioned earlier, it is a voluntary standard, and Canadian manufacturers are free to apply the standard to their product.
So it's a tool that they could use. Correct. Okay. Any other questions today? What do I need to add to my decal and owner's manuals to comply with these brake standards?
So in section 4 and 648-4, there's a list of what requirements are, or what information is required to be accessible by the operator. And let me get those in front of me. And some of that information includes just the configuration requirements, if it can be hooked up into a train of multiple towed vehicles, the maximum design ground speed, the maximum mass, the maximum transport mass, because those are two different values, and those are explained in the definition section. Maximum transport speed and the minimum recommended towing vehicle mass.
Okay. Why should my company comply with these standards?
Well, as mentioned before too, it's a voluntary standard, and it does offer some possible litigation, kind of hedging against a little bit of litigation. It does allow a little more compatibility with some of the towing vehicle manufacturers. Our industry is a little bit unique because we have all different manufacturers that can that make towing and towed equipment, and this the document provides a common interface that can be utilized.
Okay. And then you can see, Bruce, that Oliver has some questions about deceleration.
Yeah, so questions for vehicles where the vehicle has a max transport speed of less than 20 miles an hour and a load ratio greater than 1.5. And so in section 4, we talk about a deceleration rate of 1.64. And in section 5, we talk about a deceleration rate of 3.55. So this is an issue with the document. That value of deceleration was discussed a lot in section 4, and when we changed it down to 1.64, it didn't get changed in section or in document in -5. So that's a correction that's going to be needed to be made to -5 in an upcoming revision. So we are starting to collect. There are some issues like that. We are collecting those, and we thought we'd probably wait a few months before we initiate a revision to provide any corrections or additional clarifications to the documents.
Yeah, that is one thing that's unique about standards. They are living, breathing documents. The committee's reviewing them on a periodic basis and wondering if there are changes as people use them. And we will make the trade associations across North America aware of what we do in a press release if we do revise these standards and when they do get published, when they're available. So because of the interest in these documents. Okay. So then the next, it really isn't a question. It's information on where you could potentially find some of these systems. So you can see that on your screen. And if you've had interest, you've probably jotted that down. So there's no need for us to address that question. Okay, are there any special requirements for a rigid tongue implement versus steerable front axle like an ammonia cart, or is it just based off of weight of the towed equipment?
It's just based off the weight of the towed equipment as it stands on its own. So we didn't go into addressing how much was on the hitch and how much, or if it was a flexible tongue vehicle. So it's just mass of the vehicle, of the towed vehicle on its own.
Okay. Can you email both part 1 and part 2 PowerPoint slides after the meeting? And yes, that's our intent to do that. S648 part 5, section 5.6.2.1 shows a compatibility curve based only on deceleration 5. What about other braking ratio 1.64, for instance?
And let me look at that. Okay, so the way that chart's going to work, so on the y-axis is the deceleration rate from the towing vehicle, and as you move across, you're going to get your pressure range. and then down in the tables. So your pressure range for a vehicle, a towed vehicle that's got the 1.64 will have its 1.64 decel rate at those max pressures. So the table actually applies to all those conditions. If you're familiar with the way the tractor regulation is in Europe, the chart is quite a bit different. The range is a lot smaller, and then it gets into ballasted and not really ballasted, but loaded and unloaded conditions, and those bands are pretty tight. And what we didn't want to get into the unloaded and loaded situation, so we opened up the band and allowed for adjustment to occur in that area. And so that's why it looks the way it does. And but really, from the compatibility pressure range, it really applies to all. So that max decel is going to occur at that max pressure that's given by the chart. And we can discuss more on that too if you want to do it more in person also.
Okay. Anything else, Bruce, on that question?
No, not this time.
So, when do you think these standards will become mandatory in the U.S. and required by law? What year would you think? There's absolutely been no interest that I'm aware of, Bruce, in the U.S. for these standards to become required by law. And I haven't heard anything from any of the trade associations or seen anything or had any regulators contact me for information on them. However, in Canada, I have had interest from some of the provinces from the regulators, namely Quebec and Ontario. I don't know what will happen, but they are very interested in the content of these standards. Have you heard anything, Bruce?
I have not heard of any activity towards making this into a law, other than what you mentioned in the few questions you had relative to Canada.
Okay. And again, when I click to answer this question, you'll see additional information that someone wants you to be aware of. And standard is in force, question mark. Well, it's published, but I believe, Bruce, the manufacturers have time to comply with it in their design after the publishing date.
Correct. Yeah, it's up to manufacturer to kind of determine when they want to apply this to their product. From the towing vehicle side, both the pneumatic and the dual line hydraulic interfaces are generally they're definitely provided in Europe, and in most cases they're options that you can get from a North American standpoint also. So granted, it's on newer equipment, but it is available. So
okay. So I was asked if I could share the Canadian regulators contact. One I know quite well, Sauvé, with the MAFRA in Ontario. The other is a French Canadian I've met in person at a CASA, Canadian Ag Safety Association meeting. And if you send me an email, I could provide that to you. I believe I've mentioned this to AMC staff, to Donna, that they had this interest as well, and she may have the contacts if you're with AMC. What about using regenerative electric motor braking? Would that comply with the standard if it meets the performance standards?
Generally, yes, because we really tried to not be too prescriptive on things. The interface options that are cited in the standard, they're just the pneumatic and the dual line hydraulic. But we really wanted to keep the standard based more on performance requirements and how much the deceleration would be, and not limit it technically to any specific method. So as long as that braking force would be generated when only the brake pedal in the towing vehicle was being activated, and it didn't require a secondary effort by the operator to apply the trailer brakes. It would fall into compliance with what, or fall into alignment with what the standard's trying to communicate.
Okay. Thank you, Bruce. There are no more open questions. We'll give it another minute here if someone's typing something in. And if there are none, we will draw this to a close and declare victory.
So I get one point I guess I would like to make too is if there's any other questions on the standard on all five parts, I guess feel free to let Scott know, and we can discuss things more in depth also. One area I was kind of thinking of was if additional explanation or discussion need to occur on the testing methods of things. That was one area. And so yeah, feel free to bring up any more questions with anything.
Okay. Well, I don't see any more open questions coming in, so I thank everyone who's participated. I thank Bruce, you, and everyone who's helped put this together. It's been great. And with the panelists, please stay on the line after we close, and everybody else is, I guess, dismissed. So thank you, everyone. Have a great rest of your day.